Hello. In this lecture series of SSD 1306, we'll learn about how to control, display, and do some graphics over the SSD 1306, and also how to display any animation that you want, any GIF that you have onto SSD 1306. Let us proceed. The agenda is we'll slightly have a brief on the protocol I2C, and also we'll see how SSD 1306 works, and we'll also see what is the hardware configuration that we have to go for while connecting SSD 1306 with Node MCU, and we'll also see how to draw objects on SSD 1306 and how to display your own image onto SSD 1306 and animate any GIF that you have, graphical image, onto SSD 1306. If you see a basic I2C bus, I2C bus looks like this. There will be a master and the slaves connected over a bus. I2C bus mainly contains only two lines, SDA, which is the serial data line, SCL, which is serial clock line, and the bus is pulled high with some pull-up resistors. This decides the speed of the bus. So if you see our current configuration, our setup will be Node MCU connected over the I2C bus, on which the same SSD 1306 is also connected. SSD 1306 itself will have a I2C controller which tries to manage writing and reading from the SSD 1306 display. Basically, this is a OLED kind of display, which is quite different from normal LCDs what we see. If we want to know, have a brief idea on I2C bus, it works like this. First of all, whenever a master wants to speak with a slave, it will issue a start pulse or a start signal. We are not going much detail into the protocol, so we shall stick to the basics only, so that we'll have a brief idea on what is actually happening in the background. When a start signal has been issued, after which all the slaves in the bus will be listening to the master. Then master issues a slave address and also read or write bit, whether master wants to write to the slave or it wants to read from the slave. Soon after, if the slave address matches with any of the slave, the respective slave gives an acknowledgement. Thereafter, the bus is been established between the master and the respective slave. And the data exchange happens like this. For whatever data has been shared from the master or to the master, there will be an acknowledgement. And there will be, at the end of the transaction, there will be a stop. So when actually a master transmits, it transmits like this. These blue colored things are from master to slave. The green colored things are from slave to master. Master issues a write with slave address. Respective slave acknowledges, and the rest of the slaves doesn't listen. Now master issues a data. The slave acknowledges. This is how it goes. When actually the master is the receiver, it issues a slave address, and then it issues a read bit. That means the last bit of the transaction will be a read bit, for which the slave acknowledges, and slave starts sending data, for which the master actually gives an acknowledgement this time. It's actually reverse. When the master is the receiver, master has to acknowledge, and master will have the whole control to issue start and stop pulses. If you see in both of the transaction, master will have the control for issuing start and stop transactions. This is the brief introduction on I2C. We don't need to bother about all this. Our MicroPython I2C library manages all this. When coming to the hardware connection, we can use any pin as such. So in my case, I'm using D1 and D2. D1 and D2 on the hardware are equivalent to GPIO 5 and GPIO 4 when you're writing in the code. This is the hardware connection, 3.3 volts connected, and the ground. SCL line, serial clock, and SDA, serial data line, both are connected via D1 and D2. So in the demo that we are going to have, the lab1 tries to show you how can you display text, how can you display lines, and how can you draw some graphics over the display. And lab 2, you'll see how to display any image onto your display. And lab 3 shows you how to go with displaying animations over your display. Okay, let's go ahead to code. Thank you.